Okay, so since they don't have anything in common, what we're going to do is we're going to group them. And most of the time, they'll already be in the proper order. Every now and again, you might have to arrange it. But what I mean is by grouping is we're going to look at the first two terms. Okay, so specifically, we're looking at x to the third minus x squared. Do those have anything in common? Yes, what do they have in common? X, how many x's do they have in common? Squared, x squared, okay? So what I'm going to do is I'm going to pull out an x squared. And then I'm going to divide each one of those terms, just those first two, by x squared, and I'm going to write what is left in the parentheses. So if I take x to the third, and I have three of them, and I take two away, I'm left with x to the first, okay? Bring down the minus. And then x squared divided by itself, or anything divided by itself, it doesn't disappear. It turns to 1. Okay, so that's going to become x minus 1. And I'm going to close that parenthesis. And then what I'm going to do is whatever that sign is that is next, I'm going to bring it down. If it's a positive, that really doesn't have any effect on it. When we get to a negative, we'll have to discuss that. And what I want to do now is I want to group the second two terms. And I want to look at what is it that those two have in common. They have a 2. So let's pull that 2 out. If I divide 2x by 2, I'm just left with almost. Got it. You're ahead of me. Yeah. You're left with x, right? And then if I take that negative 2 and I divide it by 2, I'm left with a negative 1. So by grouping the first two, pulling out their GCF, and then grouping the second two and pulling out their GCF, look at your parentheses. What can you tell me about those? They're the same. So in this case, we now have 2 terms instead of 4. And what I mean by that is we have this counts as one single term, and this one counts as one single term. The goal is to have that leftover stuff, what stuff is in the parentheses, that is needing to be the same. Okay, because now in both of those terms, what's the same? The x minus 1. So what I can do then is I can pull out that x minus 1 that both of those have in common. Let me erase my highlighting. And so think about this. If I were to take away the x minus 1s, what is the leftover stuff? I'm going to put that in a parenthesis behind or in front of it. Doesn't really matter the order. Do I now have 2 things that are being multiplied together? Yeah. So I have factored it. The only other thing I want to check and see is can I continue to factor? So look in that first parenthesis, x minus 1. Are those both perfect squares or both perfect cubes? No. The 1 is, but the x is not. So I can't break that down any further. And then I'm going to look at the second parenthesis, the x squared plus 2. Are those both perfect squares or cubes? No. So that tells me this thing cannot factor any further, and so therefore my answer looks just like that. Does that make a little bit of sense? Okay. All right. I want you to start number 2. Look at your first 2 terms. Decide what they have in common. Pull that out, write what's left. Then look at your second 2 terms. Decide what those have in common. Pull that out and write what's left. And then we can pause there for just a second. Again, majority of the time, the box I give you, the first 2 will have something in common, and then the second 2 will have something in common. Okay, so x minus 1. If we have 2 terms, the only way we can factor is if they're both perfect squares being subtracted, or if they're both cubes. Okay. 1 is a square and a cube, but x is not, so therefore it can't break down. And then the same thing with the other parentheses. 2 is not a square or a cube.
Wait, can't you like break this down?
That's why we decided about pausing. Looking at the first 2, x to the third minus x, what is it that those have in common? Okay, and if I divide that x out, what's left? X squared minus 1, okay. Then I'm going to bring that plus sign down. What do the next 2 terms have in common? 2. And if I pull that out, what's left? X squared minus 1. Remember, the goal is to have what's in your parentheses be the same, because that's now going to be your new GCF that you can pull out. Do I have the same stuff in both parentheses? Yeah, so I'm going to pull that one out. And then what I do is just forget about those, and I write the leftover pieces in a second parenthesis. But again, I have to try to continue to factor if I can. So looking at that first parenthesis, x squared minus 1. The only way we can factor with two terms is if they are both perfect squares being subtracted, or if they're both perfect cubes. Which ones are those? X squared minus 1. They're both perfect squares. And are they being subtracted? Yes. So I can actually continue to factor this piece right here. So what I'm going to do now is I'm going to set up two parentheses. The square root of x squared goes in the front. This is like what we did on Tuesday of last week. What's the square root of 1? 1. Then for our signs, we put 1 plus and we put 1 minus. What about that second piece? Does x plus 2 factor any further? No. So we're just going to bring that down. The order of the parentheses is not important, as long as you have 3 sets of parentheses. One with an x plus 1, one with an x minus 1, and one with an x plus 2. Kind of okay with those? Somewhat? Sort of? Okay. All right. Take a minute and write number 3 down. This one is slightly different simply because that middle sign, and we'll talk about that in just a second once you get a chance to write it down and then we can start looking at it. So I have to look at both of these, and because that's a perfect square, and they're being subtracted, we have to use the pattern of the difference of squares to break it down. You can only do that if they're both perfect squares being subtracted. All right, so let's look at the first two terms. 2x squared plus 2x. What is it that those have in common?
2x.
Okay. So let's pull that out. That's going to leave me with an x plus 1. Now, in the first two, the next sign was a plus, and so we brought that down. What's the next sign in this one? A minus. So we are still going to bring it down, but that's going to change a little bit for the rest of the problem. And this is also something people struggle with. Do those have anything in common?
No.
No. Okay. But you have to pull something out. So if your two terms don't have like a 2 in common or a 3 in common or an x in common, you have to pull something out. So what's the only thing that we can pull out that everything has as a factor? 1. Okay, so I'm going to have to put that 1 there, but specifically what kind of 1 is it that I just pulled out? A negative 1. So when I write my leftovers, we have to think about it as dividing each one by a negative 1. Okay, so think about this. I started with negative x. If I divide that by negative 1, what does that turn to? A positive x, right? And then I'm going to do the same thing with that minus 1. If I take a negative 1 and I divide it by negative 1, I'm left with a positive 1. So in my parentheses, I should end up with an x plus 1, which is what I needed for it to be the same as the other problem. Does that make a little bit of sense? So when that middle term is negative, you have to think about it as pulling out a negative number. And when you divide each term, you're going to basically change their signs. Then we can continue. My x plus 1 is the same, which is what I need it to be. So I'm going to pull that out. And then I'm going to write the leftover pieces in my second parenthesis. Can I continue to factor either one of those parentheses? No. Okay, so that is going to be exactly how I leave my answer. I want you to try the next one for me. Okay, very similar. Look at the first two terms. What is it that they have in common? Pull that out, write what's left. Look at the second two terms. What is it they have in common, but specifically That middle sign is a negative, so when we pull it out, we have to pull it out as a negative. What do the first two terms have in common? X squared. And if I divide each one of those by x squared, I'm left with, okay. And then remember, bring down that minus sign. And when we do that, the number that we're pulling out is a negative. What is it that the second two have in common? Okay, so we're dividing each by a negative 3. So negative 3x divided by negative 3 becomes a positive x. And then negative 3 divided by negative 3 becomes a positive 1. So basically, when this middle sign right here is negative, you're going to change the sign of both of those in your parenthesis. Okay, that's kind of how that's working. And then I did end up with the same stuff in my parentheses, so I can pull that out. And then I'm going to write the leftover pieces in another parenthesis. Can I factor x plus 1 any further? No. Can I factor x squared minus 3 any further? No. X squared is a perfect square, but 3 is not. Therefore, I cannot continue to factor that, and we would leave the answer just like that. That make a little bit of sense? All right. I want you to try both of those. These are the last two. Oh, actually, no, let's do 5 together, and then I'll let you try 6. Write 5 down. Yes. I have 3x to the 5th plus 15x to the 3rd minus 9x squared minus 45. And I forgot to ask you this question, 1, 2, 3, and 4. But what is the first question we're supposed to ask ourselves? Do we have a GCF? So we need to look at all 4 terms. We have a 3, we have a 15, we have a 9, and we have a 45. What are all of those divisible by? 3. So we're going to need to pull that out first. Divide each term by 3. Now start the same process over again with the stuff in the parentheses. Look at the first 2 terms. What do they have in common? Remember, we're not going to lose the 3 that we pulled out. Okay, I'm going to hold on to that for a minute. What do these 2 have in common? X to the 3rd. And what's left if I pull that out? Okay. Bring down that minus sign. What do the second 2 have in common? 3. And if I divide that by a negative 3, I'm going to be left with x squared Thank you. I haven't lost that 3, and you'll notice I left a little bit of space because I don't want to get it confused with that x to the third. It doesn't belong with that x to the third. Okay, I'm keeping the 3 in the front. What is the piece that's the same? Okay, so that's going to go in my parentheses. And then we can write the leftover parts after I remove x squared plus 5 in my next parenthesis. And so that's going to be x to the third minus 3. And if you notice, I kept that 3 in the front. It does not go in the parentheses with anything. Anytime you pull a GCF out, it's going to be left in the very front, not included with anything else. Now we just need to check. Can I factor x squared plus 5 any further? No. Can I factor x cubed minus 3 any further? No. So this is exactly how we're going to leave that answer. Number 6 is very similar. I want you to try that one. Sometimes I forget to ask them. I see it doesn't have it, but we need to get in the habit of that being the very first question I ask, no matter what kind of factor we do. When you do pull out a GCF, if it helps you, like when I pull that 3 out, maybe just skip a couple of lines and put that 3 in the front, and just know that it's going to be included in your final answer. What is it that all 4 terms have? A 2. So I'm going to start by dividing each one of those by 2. Okay. I'm going to leave that 2 out front. I'm going to focus on the first 2 terms. What do those have in common? X squared. Okay, so I'm going to pull out that x squared. That leaves me with x minus 9. Okay. Bring down your minus sign. What about the second 2 terms? What do they have in common? 4. And remember, we're dividing by a negative 4. So negative 4x divided by negative 4 becomes a positive x. What is a positive 36 divided by negative 4 become? Negative 9. Remember, we need the same thing in the parentheses, which we do end up with here. I'm keeping my 2. I'm going to pull out my x minus 9. And then remember, your leftover parts go in your second parenthesis. Is everybody following so far? All right, and then we need to see if we can continue to factor, starting in your parenthesis, x minus 9. Can that factor? No, 9 is a perfect square, but x is not. What about x squared minus 4? Those are both perfect squares, so that can continue. Bring down your 2. Bring down your x minus 9. Then set up your 2 parentheses. The square root of x squared is x. The square root of 4 is 2. And then what do I do with my sides? 1 plus 1 minus. And that is the completely factored final answer. Anybody have any questions? Pretty straightforward.